our skeletal muscles as well as in the liver. If it is in excess, glucose is there also. It can be transformed into what? Fats. As triacylglycerol, okay, in adipose tissue. Glucose also used for the biosynthesis of glucuronuric acid, glucosamine, and galactosamine, galactose, non-essential amino acids, and so on. These are some of the importance of glucose. Okay, it's a major carbohydrate. It's named as blood sugar. Can be stored in our body in the form of glycogen. Can be changed into ribose, and this ribose can be useful part of nucleic acids, and can be changed into galactose for the formation of milk. It can be part of glycoproteins and protoglycans. In some way, it can be present in LDL form. LDL is nothing but it is one form of lipoproteins. We do have 5 lipoproteins: chylomicrons, VLDL, intermediate density lipoproteins, LDL, and HDL. If an individuals which have amount of LDL than the normal ones, these individuals will be high risk of developing atherosclerosis or heart disease in general. The higher LDL, the higher incidence of heart disease. The higher HDL, it is inversely proportional to that of atherosclerosis. The higher HDL, the lower risk of developing atherosclerosis. And glucose also part of glycocalyx. How glucose can be entered to our cells? Through insulin-independent transport system or through insulin-dependent transport systems. As I mentioned earlier, glucose can be stored in the form of glycogen in the liver as well as in skeletal muscles. And muscle and liver adipose tissue, when it is excess this glucose can be stored in the form of triacylglycerol in adipose tissue. Now, adipose tissue and muscles can get glucose from the blood in insulin-dependent systems. After meal, the concentration of glucose becomes high, and our pancreas synthesizes insulin, and insulin concentration will be increased. Therefore, muscle and adipose tissue will get glucose through insulin-dependent transport systems, and it uses glucose transporter 4. Whereas manners by using glucose transporter 1. And glucose transporter 1 actually, glucose transporter 1 actually has low Km value for glucose. The lower the Km is, the higher affinity with glucose. Even blood glucose levels can be low. Glucose transporter 1 is easily saturated to transport glucose from the blood to reach to the organs. Therefore, cancer cells, okay, cancer cells are mainly dependent on glucose, and cancer cells are highly synthesizing glucose transporter 1 and glucose transporter 3, since both of them has low Km value. That means the lower the Km is, the higher the affinity. Okay, the higher the affinity. Even if there is low amount of blood glucose levels, cancer cells will be able to get easily glucose by glucose transporter 1 and 3. Disorders associated with glucose, excess glucose in the blood may lead to hyperglycemia. If it is present in the urine, it's named as glucosuria. This is the indicator of DM patients. And excess glucose in our eyes, for example, if the DM patient unable to control his blood glucose levels, this glucose level in our lens may be changed into what? Changed into sorbitol, and one of the complications of DM is individuals may develop cataract. This is due to accumulation excess glucose. The other simple sugars, D-fructose, and here, while you are studying biochemistry, it is better to know what makes unique from the others. Here, what makes D-fructose unique from the rest simple sugars? D-fructose is the most sweetest sugar of all simple sugars. It is the most sweetest sugar. And as I mentioned earlier, glucose is utilized by most of our cells. But here, what makes unique? Seminal fluid is rich in fructose. It is a main sugar for semen. That means it serves as a nutrient for sperm cells. In seminal first tubular epithelial cells, fructose is formed from glucose. And when fructose on reduction, it can be able to form what? Sorbitol and mannitol. And if during fructose metabolism, if there is lack of an enzyme for metabolizing fructose, individuals may develop essential fructosuria. And fructose in the liver can be changed into what? Glucose. The other is D-galactose. Okay. Here, D-galactose, its source is here. D-galactose, its source is dairy products. And D-galactose is not as such found freely alone in nature. It's never found free, or rather, it is part of milk sugar-like lactose. It's part of mucopolysaccharides. It's part of GAGs, or glucosaminoglycans. And it is a constituent of glycolipids and glycoproteins. And it is very crucial for development of brain and nervous tissue in infants. Therefore, as you know, milk is very essential for infants. It can become galactose also converted in glucose in the liver. Accumulation of it may lead to galactose or cataract. The other is mannose. It can be found in plants. Its biomedical importance is mannitol, that's the reduced form of mannose, can be useful as a diuretic effect for treating acute renal failures. Now, what are the derived carbohydrates? Okay, whenever carbohydrates or simple sugars are oxidized, it will form sugar acids. Undergoing reduction, it will form sugar alcohols, or some OH groups can be replaced and it may be added or replaced by amino groups. It will form glucosamine, galactosamine, mannosamine, and so on. Or the OH may be, or the hydrogen, or the OH may be modified, and it may be able to form deoxyribose, which is a component of DNA. Now, based on the type of carbons, sugar acid can be different forms. Uronic acid, for example, if in the case of glucose, oxidation of aldose at primary alcohol, okay? This is the last OH. The primary alcohol, if undergoing oxidation, glucose can be changed into uronic acid. If both the aldehyde group and the terminal alcohol undergoing oxidation, the molecule is named as saccharic acid. If the aldose group is oxidized, the molecule will form aldonic acids. For example, the most important uronic acid in human beings are D-glucouronic acids. Here, D-glucouronic acid is very important for us for detoxification reaction, okay, for certain drugs, and even in order to transport the metabolic end product of hemoglobins or heme proteins. One of them is bilirubin, and the bilirubin is less soluble in water. Now, when it binds with glucouronic acid, it enhances what? Solubility with water, and these molecules can be really easily removed from our body parts. And most of the derivative of monosaccharides are, it is an important part of connective tissues, especially in the form of glucosamino-glycans. Oxidation, the terminal alcohol, whenever it is oxidized in glucose, it will form glucouronic acid. And glucouronic acid is very crucial in order to enhance the solubility of drugs, the solubility of bilirubin for detoxification reactions. The other is reactions. If simple sugars can undergo reduction, it can able to form what? Alcohols. Okay. Glucose, it can be reduced to sorbitol. Mannose, it can be reduced to mannitol. Fructose becomes reduced into sorbitol and mannitol, and so on. Now, sugar alcohols are sometimes called polyols or polyhydric alcohols or polyalcohols. For example, glucose can be changed into sorbitol. For example, let's see now. Okay. Let's see now here how DIM complication leads to cataract. How DIM complication leads to retinopathy, nephropathy, neuropathy. All of them has its own biochemical consequence. For example, in seminal vesicles, okay, in seminal vesicles, as I mentioned earlier, fructose is what? It's the best or the energy source for sperm cells. Now, how fructose is synthesized? Through the help of what? Sorbitol dehydrogenase. This sorbitol dehydrogenase is found in liver, ovaries, and seminal vesicles. Here we have glucose. When blood glucose is excess, through aldose reductase, it can be changed into what? Sorbitol. Now, sorbitol has high attraction force for water molecules, and the shape of the lens becomes changed, and individuals may develop cataract when blood glucose levels are elevated in lens and nerve and our kidneys. But in seminal vesicles, through the presence of an enzyme called sorbitol dehydrogenase, sorbitol is changed into fructose. This is how complication of DM leads to what? Cataract. When there is excess amount of glucose, this glucose is changed into sorbitol through aldose reductase, and sorbitol will not be changed into fructose due to the deficiency or lack of or devoid of the enzyme called sorbitol dehydrogenase. And now, since as I mentioned earlier, this sorbitol has what? It's high osmotic agent. Okay, it can hold what? Large amount of water. Therefore, it can act as an osmotic laxative for those individuals which have chronic constipations. Chronic constipations. Constipation can be relieved by taking enough amount of fibers. Those individuals which eat enough amount fibers can reduce the chance of developing colon cancer, can decrease chance of developing constipation, and so on. Therefore, this sorbitol, the lactulose, and here some of them are listed, has osmotic laxative effect, and it can be prescribed for individuals which are able to be treated with constipation. These are the structure of lactulose, and it can be useful as of constipation. The other is amino sugars. Amino sugars are derivative of simple sugars. Instead of OH is replaced by amino group. These are some of the examples: galactosamine and glucosamine. Both of them are useful mucopolysaccharides or glucosaminoglycans. These are the structure of amino sugars. Here, the OH is replaced by the amino group, and again the amine group, the hydrogen, may be acetylated, okay, and it will form N-acetyl galactose amine. These are some of the amino groups, and here where these amino sugars can be found. For example, glucosamine. It's part of hyaluronic acid, part of heparin. And heparin is one of the natural anti-coagulative effect. Okay, heparin is heteropolysaccharide molecules, which is made by more than 10 repeating units of disaccharide units. That means whenever heteropolysaccharides are hydrolyzed, it will produce more than one simple sugars. Whereas homopolysaccharides like glycogen, when it is hydrolyzed, it will form glucose, one form of simple sugars. Whereas heteropolysaccharides, whenever it is hydrolyzed, it will form what? More than one simple sugars like heparin. And the blood group substance also contains what? Glucosamine. Galactosamine is also found in glucosaminoglycans like chondroitin sulfate and so on. Can you hear me? Okay. Now the other part here is glycosides. Okay, glycosides are nothing but this derivative of sugars. Okay, here glycosides are nothing but, for example, when we consider disaccharides, disaccharides are carbohydrates which is held together by glycoside linkage. And when glycoside linkage is formed, one water molecule is what? Released. Now here glycosides are its derivative of sugars. How they are formed? The OH group of anomeric carbon of a carbohydrate can join with the OH group of another carbohydrate or some other compounds to form a glycoside. The bond formed here is glycosidic bond. The non-carbohydrate moiety is called aglycol. The bond may be N or O type. Now we do have sugar molecules and aglycol molecules. Moiety means this small part of it. Okay, here we do have sugar through acetyl linkage, and we do have aglycol. That is a small part of what? The glycoside is called aglycol, which is non-carbohydrate one. And this molecule has what? OH group. Okay, OH group. Aglycol moieties like non-sugar hydroxyl containing compounds. These are methanol, sterol like cholesterol, phenol, glycerol. All of them can act as what? Aglycol. Therefore, where it occurs and what is the use of glycosides? Glycosides are a natural occurring substance. It can be present in plants or animal bodies, and it is extracted and it is useful as drugs. Okay, these are some of the drugs which are produced as a derivative of simple sugars, like dioxin. Okay, I think you are familiar with dioxin, which is given or prescribed for those individuals which have cardiac insufficiency, in order, since it enhances cardiac muscle contraction. Now here in dioxin drug, the aglycol part of it is steroids. Okay, steroids are the aglycol part. The other drug, streptomycin, which acts as an antibiotics, which is given for tuberculosis, are produced through derivative of simple sugars by means of glycosides. Polarizing, this also an example of glycosides, and polarizing is a glucose transporter inhibitor, okay, and which is given for individuals which have DM. Okay, the next part is disaccharides. Lazarus 𝑔 You have questions? Yes. Can you hear me? Samachwan? Lazarus 𝑔 Can you hear me? So much on? Okay, chat ላይ ከላካችሁልኝ ጥያቄዎች መካከል ለምሳሌ what is the difference between D and plus assignation የሚለው ነው. D indicates only the optical isomerism of OH, whether the OH is on the right or on the left. If OH is on the right, like D-glyceraldehyde, we will assign it D. D indicates what? The OH is on the right side on the asymmetric carbon. D doesn't indicate the rotation when we place it in optical isomerism. Plus sign indicates when we put this molecule in plane polarized light, the light may rotate on the right direction or it may rotate on the left direction. If it rotates on the right direction, we will add plus sign. We will add plus sign. If it rotates, we will add minus sign. Therefore, D indicates what? Optical isomerism. Plus indicates when the molecules rotate the plane polarized light on the right direction. Plus sign will not indicate the OH is on the right position. A molecule may be D, but it may be minus or it may be plus. For example, D plus glucose, D minus glucose. Optical isomerism, plus indicates the rotation of the molecule. Is there anyone?
አለ
እሺ ጥያቄዎችን እያየሁ ነው ቻት ላይ ያሉትን
ተማሪዎች የሁለት ሴክሽን ተማሪዎች ዛሬ ከሰዓት አላቸው ላብና ግዴታውን ባስ ስለሚሄድባቸው የሚል ነው። ይህን ትምህርት ወይ እቺን ፓርት ክላስ ነገ መቀጠል እንችላለን? ከዚህ ተነስተን
the next ስላይዶችን ነገ እንቀጥላለን። ነገ ነገ ናችሁ ሊፒድ እና ካርቦሃይድሬት
ከዚህ ፓርት ተነስተን
ከዚህ ነው የምንነሳው ከዳይሳካራይድ
ተማሪዎች እየሄዱ ስለሆነ ነው አበዛ ባስጥሩ ይደርብና
ኖ ፕሮብሌም። ለዛሬማ በቃ ጨርሻለሁ። እኔ ቻት ላይ ያሉትን ጥያቄዎች ዝም ብዬ እያየሁ ነው።
ኦኬ እሺ
ሰላም ነው።
ጥያቄ አላችሁ?
እሺ ጥያቄ ካላችሁ ወቂ
እዚህ ብሩክ የጻፈው አለ።
ማን የጻፈው?
ብሩክ ለሁላችንም የጻፈው።
እሺ ብሩክ ምን የሚለው ጥያቄ ነው? ልታነብል ይችላለህ?
Hey, what's the difference between D and plus?
Okay. እሱ ምን መሰለህ? D ማለት D is only to refers to the spatial arrangement of OH. OH በቀኝ በኩል ከተቀመጠ D ነው የምንለው። If OH is on the asymmetric carbon, if OH is on the right side, it becomes D. በዲ ተቀምጦ አንድ ሞለኪል ዲ ተቀምጦ ማይነስም ፕላስም ሳይን ሊኖረው ይችላል ማለት ነው። ማይነስ ሳይን indicates what? Optical activity. When we put this molecule on plane polarized light, the light may rotate to what? The left direction. That's laboratory. It is designated as minus sign. Okay? Minus sign. If it is on the right direction, it becomes plus sign. Plus sign will not indicate the molecule belongs to D. Plus sign will not indicate the molecule belongs to D type of simple sugars. Plus sign only indicates optical activity, whereas G and L refers to optical isomerism. Yes? Does gluconeogenesis occur and help in metabolism of patients with hypoglycemia? Yeah, it helps. It may not be as a long-term solution, okay, but occasionally they are able to help to manage their blood glucose levels by gluconeogenesis from glycerol, from propionic acid, from pyruvate, lactic acid, and from gluconeogenic amino acids. But at the same time, they are sacrificing their body proteins to degrade for formation of glucose rather than those proteins to do their own job. Can you hear me, Samachwa? Yes? Okay, I will ask you one question. Do you think our body can make glucose from fats? Do you think our body can make glucose from fats? Say the answer is yes or no. If you say yes, you can make thumbs up, or if you say no, you can make it stop. Do you think our body can make glucose from fats? Yeah, our body can make glucose from fats. Fats mean what? Fat ማለት fat is to mean triacylglycerol. Okay, fats means triacylglycerol. That means it has glycerol plus 3 fatty acids. Glycerol is a major substrate for gluconeogenesis. ስለዚህ fats ማለት glycerol አንዱ የfat part ነው ማለት ነው. Now my question will be, do you think our body can make glucose from fatty acids? Do you think our body can make glucose from fatty acids? Do you think? Okay, now we do have 2 forms of fatty acids. Okay, we do have 2 forms of fatty acids. These are even number fatty acids and odd number fatty acids. Even number fatty acids means like 2, 4, 5, 6, 8, 10, 12, 14, 16. These are even number fatty acids. And even number fatty acids are common in our body. Whereas odd number of fatty acids are like carbohydrate, fatty acid in which the carbon has 3 number, 5, 7, 9, like that. Odd number of fatty acids. When odd number of fatty acids are, or in general, when fatty acids are oxidized, it reduces by carbon 2. I'm sorry, if you have a fatty acid which has 12 number, 1, 2, 12 number, after one cycle of beta oxidation, the fatty acid is reduced by 2 and it becomes 10 carbon and 1 acetyl-CoA, and then 8, 1 acetyl-CoA, 6, 1 acetyl-CoA, 4, 1 acetyl-CoA, and 2 carbon, and then 1 acetyl-CoA. And these 2 carbons, the remaining 2 carbon is considered as an acetyl-CoA. So when even number of fatty acids are oxidized, then the product is acetyl-CoA. Whereas odd chain fatty acids are oxidized. Like for example, if you start from 7, it becomes acetyl-CoA and 5, and then acetyl-CoA. The remaining amount is 3 carbon compound. This 3 carbon compound is called propionic acid. Now our body can make glucose from propionic acid, but the amount is almost negligible. Okay, so our body will not able to make glucose from even number fatty acids. Our body will not able to synthesize glucose from even number fatty acids, but from odd chain, logically speaking, it can synthesize glucose from propionic acid, but the amount is almost negligible.
Hello?
Yes.
ይህንን ፓወርፖይንቱን ፋይል ለማጥናት እንዲመች መቀበል እንችላለን?
ትችላላችሁ።
ኦኬ ወይ
የት ናችሁ? እናንተ የት ናችሁ? እዚህ ግቢ ናችሁ?